So congruence and similarity. To get kids to try to recognize what it's talking about, either of these terms you can think about going up to a photocopier. If you make an exact copy, you're making something congruent. Now if you go up to that photocopier and you say, I want to enlarge something, I want a bigger version of it, or I want to reduce the size, I want to make a smaller version of it, or even if you say, I want an exact copy, then you're making something that's similar. So similar is when it has the same shape, but it could be a bigger version, it could be a smaller version, or it could actually be the same size. Then it's similar, so it has the same shape, just a bigger or smaller version. If you're doing something other than looking at the notes that we're going over, then you're not focused, and that's something that could go on your assessment sheet. So, congruent figures oh, my U looks funny. I can't unfunny it. C-O-N-G-R-U-E-N-T figures are exactly the same size and shape. Now I've got some spatial relation type issues, so sometimes if I really can't tell, I will actually sort of put a copy over something, and I will fill it in, and then I will manipulate it, and I might rotate it. I might even flip it over if I need to see if it matches up, because I can't visually in my brain turn things around and flip things over. So you could, in your brain or physically with the paper, do transformations. To make one fit over the other. The word transformations, when you're talking about translations, where you actually just move it over and you can make it line up. It talks about rotations, where you turn it a certain amount of degrees, and therefore you might be able to make it line up. Or reflection is when you flip it over and you look at the mirror image of it. And you might have to do a combination of transformations. So in this example here, we have trapezoid MATH is congruent to trapezoid BEST. You can also do some measurements. So for this one, I might take out a ruler measure, or I might do that thing where I note how long it is to go from this point to this point. Hey, look at that. Over here is the same exact length. And so I can determine that this is congruent to that one. Then I might look at the small side, the T to the H or H to T, however you want to talk about that line segment, and go, this one goes from here to here. Look, that one goes from there to there. Perfect. So this one is congruent to that one. And then this happens to be isosceles trapezoids. So those slanted sides are all the same length. So this over here goes to that over there, which is the same as that over there, and that one over there. So you can actually do measurements to check the sizes, or just comparisons. And in this case, trapezoid math is congruent to trapezoid best. Math is practically best, is what it's saying. It's pretty much the same as best. Math is best. Anyway. Congruent symbol, an equal sign with a squiggly on top. If you have the double squiggly, that means approximately equal to. If you have a single squiggly, that's going to be similar. But an equal sign with a squiggly on top means congruent to. You're going to need the notation for tonight's homework.
How do you tell which these are there?
Huh? So it's an equal sign with a squiggly on top. Just like a weave. It goes up and then it goes down and up. I'm going to clear the ink and scroll it down. So look at similar figures. And then at the very bottom we'll do homework problems similar to tonight's homework. So similar figures are the same shape, but not necessarily the same size. So again, I personally sometimes have trouble going, is that a bigger version of that? I don't know, that could be a little bit longer on one side in comparison to that. So it's about keeping things in proportion. But if I really can't tell, sometimes I will take, again, a drawing of the shape And as you move something, I take the smaller one, because as you move something closer to your eye, it starts looking bigger than what's staying flat on the table. I've done this trick before. And you can actually make it so that it will fit over it perfectly. And therefore you can see that they're exactly the same shape, but one of them was smaller, and as I moved it closer and got it bigger looking, it fits exactly. But with triangles, you don't have to do that, you can just measure the angles. So triangles are similar if their angles are congruent. But this is not necessarily true for other polygons. So if you think of a perfect square as opposed to an oblong rectangle, they're not the same size, just one's a bigger version of the other, and yet they have 4 90-degree angles. So you can't just look at the angles for most shapes, but with triangles you can. So for this triangle here, we have triangle RED. It's a right triangle. And the angle that shoots off of the longer leg of the right angle could be measured and compared against this right angle's longer leg angle, and it might be congruent. And then if I look at the right angle's shorter leg and the angle that's formed there, and I compare it against the angle formed here, I can see with the triangle that they are congruent. So the angles are congruent, therefore triangle RED is similar to triangle SOX. Red Sox. All of the numbers stay in proportion, which we're going to do with Unit 8, keeping things in proportion.
So what's the difference between the equal sign and the squiggly line over it and just the squiggly?
So this means they're similar. Notice triangle RED is bigger than triangle SOX. So this one is an enlarged version of that one, or that one's a reduced or smaller version of that
So
one.
you do the equal one, it's like they're exactly the same?
Mm-hmm. So the equals with the squiggly over, it's like they're equal to each other, but you know, they're not exactly. They got different points on them and that sort of thing. So tonight's homework is very much like what we have down here, where you're going to have 5 or 6 shapes, and they're going to ask you to figure out which ones are similar and or which ones are congruent. The front side of homework is just about congruency, so you're just looking for things that are the exact same. But you might have 2 things that are the exact same and 2 other things that are the exact same. So the directions on that side say to circle the ones that are the exact same and then draw lines connecting those. Versus on the other side, it's about similarity and congruency, and on that side you'll use the notation. So go ahead on this example down here with A, B, C, D, and E. Try to use the notation to indicate which shapes are similar to each other and which of these shapes are congruent. You can tell me which of these 1, 2, 3, 4, 5 shapes are similar. Which ones have the same shape but not necessarily the same size? Yes, ma'am.
Me?
Mm-hmm.
D and A.
D and A are similar. C and E are also squares, just turned on their side.
Oh, you're supposed to say no, I thought it was just 2 they do.
So when it asks you for what things are similar, you could have a whole bunch of things that are similar. So in this case, instead of saying A is similar to C, and C is similar to D, and D is similar to E, and A is similar to E, and making all these pairings, I can just say that A is similar to C, which is similar to D, which is similar to E. And that way we get all of the relationships, how they're intertwined. So for similarity, I could have some of them are actually congruent to each other as well. A and C and D and E are all perfect squares. Which ones are the same exact size as well? So give me one pair of congruent shapes. Yes, sir.
A and C.
So A is congruent to C. Now, if I didn't think that something could be similar if they're congruent, when I said A is similar to D, then I go, well, how do I also let it know that C is congruent to D, and then I have to deal with all that pairing thing. But if something's congruent, it's automatically similar. So a whole square is a rectangle, but a rectangle is only a square if it meets criteria. Anything that's congruent is automatically similar, but it's only congruent as well if it's you know, the same size. Are there anything else that are congruent? Yes, sir.
D.
Ooh, yeah, both of you got it. D is congruent to E. So A is congruent to C, and D is congruent to E.
If there was a rectangle like B, only bigger, we
Mhm.
put like a comma after A, similar to C, similar to D, similar to E, and then add B and F because they're not the same like A, C, D, and E.
So basically the question is, if I had, let's say, a smaller version of rectangle B, it would have to be in proportion and all that stuff, which I can't even draw. But if it was, that's supposed to be an F, then you would have to say, and B is similar to F, yep. Because it doesn't fit the similarity of those, but it is similar to each other. Now I might have to change my notes, because that's a good idea. That got me thinking. Yes, ma'am.
So if a shape is turned like C or E, it doesn't affect its congruence?
Isn't that annoying?
Yeah.
So shapes, even if they're turned, it's still the same shape, even though they're not the way they're usually presented to you. Just like a trapezoid, you usually think it's got the parallel base and the parallel top, but it could be turned on its side and, you know, parallel, it could be angled. Yeah, shapes are tricky like that. You'll often see me either turning my head like a dog that hears a funny noise, or turning the paper. Come on, okay. Oh yeah, okay, if I look at it this way.
Yeah.
So you can turn your paper or turn your head to try to see it in the different angles.